So what we've looked at so far with the periodic table, we've talked about groups, we've talked about periods, we've looked at the patterns on the periodic table as far as classes, how all the metals are on the left-hand side, the non-metals are on the right-hand side, then we have the metalloids all grouped together in the staircase on the periodic table. So what we're going to do right now is start looking at the families. So the reason that families are grouped the way they are is they all have really similar properties. So as we look at the families, all the elements that are grouped together within that family have similar physical or chemical properties that make them all related. Okay, so we're going to color this together. Let's start with, I'm going to start with red. I'm going to start with the alkali metal family. So what we have on the left-hand side here, you're going to color this in. These are all our alkali metals. And what they have in common, you'll notice that we did skip this top element, hydrogen. Hydrogen is not part of the alkali metal family. So all of these here are metals. And what I want to do is start telling you kind of in a way that'll help you remember all the properties of the family. So let's relate it to our own families. So think about your family for a second. And we know Thanksgiving is coming up. Hopefully everybody's going to get together with their family, or even think about family members that you don't see too often, and try to relate these families that we talk about on the periodic table to maybe people that you know, or maybe even people at school that you may know. So what the alkali metals all have in common is that they are the most reactive metals on the entire table. So when I think about my family, I think about the reactive or maybe the grumpy, and it makes me think of like some of the old people maybe. So maybe grandparents or older aunts and uncles, because they're very volatile. So what happens, maybe you took the remote and changed the channel, and your grandma was watching something, so she gets very angry. So what these metals all have in common is they're very, very reactive. Anything that comes in contact with them, they may explode or be fiery. You're never going to find these elements pure in nature. So anytime they come in contact with anything, they want to react, and they want to bond, and they want to become a compound. So you're never going to find these elements. Let's see. That would be lithium, and let me pull out the periodic table. So your alkali metals include lithium, sodium, potassium, rubidium. That's all these guys here. They're never found pure in nature, so that's a good fact about this family. Another thing that we will see later in this unit, which is pretty cool, we are going to bring in sodium. Sodium, alkali metal, very reactive, not safe for humans to touch. So all of these elements we never want to hold in our hands, again, because they're reactive. We don't want them catching on fire, reacting with the moisture in our skin. So sodium is very, very explosive with water. Anytime that you bring it in contact with water, and we're actually going to do this at one point, where we bring you outside and spray some water on sodium, you'll see that it catches on fire. So keep that in mind. Your alkali metals, as far as your family, those are the old people, very volatile, super reactive, can't hold in your hands, not safe to touch. All right, I'm going to move over to, okay, let's talk about hydrogen, since we kind of left hydrogen out. Hydrogen is in a family of its own. So pick a different color there and color hydrogen whatever color you want. Hydrogen is the loner. So hydrogen doesn't really like to talk to anybody, doesn't have too many friends, stays by itself, family of one. One of my students actually said kind of the homeless person, the person all by themselves, unfortunately. Hydrogen is, as we talked about earlier, a non-metal. So it's kind of weird that hydrogen's over here on the left as a non-metal, being on the metal side of the table, surrounded completely by metals. But there's a reason for that. Hydrogen, being a non-metal, has one valence electron, right? It is in group 1, so it has one valence electron, just like the alkali metal family below it. So it acts very similar to the family below it. Again, although it's a non-metal, it acts reactively, just like the family right below it. So because it is kind of like the alkali metals, but not like the alkali metals, it becomes a family of its own. All right, next family we have, I'm going to continue on with this rainbow pattern, excuse me. The next column, whoop, my coloring's a little sloppy. This is the family called the alkali earth metals. Think about your family again. All of these alkali earth metals, they are pretty neat because They all have the property of being very colorful when lit on fire. So these tend to be used in fireworks. This is beryllium, magnesium, calcium, strontium, barium, radium, all of these elements, very pretty vibrant colors that come out when you burn them. So maybe in your family, anybody with dyed hair, maybe you have dyed hair, some bright colored clothes, maybe a hippie in the family, very, very bright, fiery part of the periodic table. So they're pretty cool. Next, we're going to look at the transition metals. The transition metals are very large. This part of the family, so all of these are all metals. So everything we've talked about, except hydrogen, these are all metals so far. So transition metals, all metals, 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 metals. Oops, sorry, my coloring's getting crazy. And what this family has in common, the transition metals, is that they are all kind of very different. We've talked about the fact that they don't follow the valence electron rule. So let's get over here. So this is group 3, group 4, group 5, group 6, group 7, and so on. And they don't follow the valence electron rule, so I can never definitively say that all of these elements here have 3 valence electrons or 4 valence electrons. We talked about them being a mixed bag of valence electrons. That is also the same, being a mixed bag. They all vary with their properties. So they're really all grouped together because they are so different. Although they're all metals, you're going to get some that are more reactive than others, and other variations of properties within all these elements that we colored green here. So if you're thinking about your family and Thanksgiving dinner, this is the big chunk of your family. Most of the kids and most of the cousins and most of the close relatives, aunts, uncles, just the bulk of your family. The fairly normal, average chunk of your family. Nothing too out of the ordinary when it comes to these elements in the center. Okay, moving over to BCNOs. Let's do a light blue. So your BCNOs. Okay, something if you haven't already noticed it, BCNO. If you look at your periodic table, these right here, this is boron, the B, that's where the B comes from, carbon, C, N for nitrogen, O for oxygen. So that's where we get the BCNO name from, because it's all the elements found right below those 4, boron, carbon, nitrogen, and oxygen. What you're going to see about the BCNO family, what they have in common and why they're all grouped together, is, I guess, for the same reason that transitions are grouped together, but this BCNO family, this is your extended family. They look a little different. There's such a variety of looks and attitudes and personalities all mixed into this BCNO family. So maybe even if you have people that come over for Thanksgiving that aren't even blood related, if you have that aunt, uncle, friend, they're just so close that you invite them over. So they don't have your same blood, but you consider them family. They're all going to be grouped together here. And the reason that there's such a wide variety of properties within the BCNO family is because, if we remember, that staircase is found right in here. And what do we find around the staircase? Our metalloids. So you're going to find your metalloids right around here. We have our metals beneath the staircase, and we have our non-metals. So 3 very different classes. Remember, metals are shiny and malleable and ductile. So metals have very different properties from your non-metals in the BCNO family. Your non-metals are your brittle and dull and non-ductile and non-malleable and fairly unreactive. So you have unreactive, you have really reactive, you have some kind of in the middle. Your metalloids are a little bit of everything. So your BCNOs, the extended family that all look very different, it's still family. Halogens. Your halogens are right here, so that's another family. Oops, I meant to color that purple. Your halogens, that's just this column, all group 17. That whole column, group 17, those are considered to be your halogens. Halogens are non-metals, they are poisonous, and they are really reactive. So this is your family that is the most reactive non-metal family on the table. Knowing that it's in group 17, there are 7 valence electrons. And we'll get to that a little bit later why 7 valence electrons means really reactive, but for now, know that the halogen family, really reactive non-metals. So I did mention that they are poisonous. So as far as your family, these are the toxic people. If you have anybody in your family that maybe makes really bad decisions and you don't want to consider them family, but they're family, they're still there on Thanksgiving, those are the toxic, poisonous elements and family that are on this table. Last column, let's see what color we're going to use. Let's do these in brown since I'm running out of colors. This last column, group 18, has 8 valence electrons, except for helium. Remember, helium is this top one. Helium only has 2 electrons, but still part of the family, although it has 2 valence electrons. This whole family is called your noble gas family. These are going to be your really rich, fancy people that come over for Thanksgiving. And the reason that they are rich and fancy and noble is because they have a full valence shell. They are completely unreactive elements. They do not react with anything. They don't need to gain or lose electrons as we get into bonding. We'll understand that a little bit more, but their outer valence shell at 8 or at 2, if you're helium, is full. It doesn't need to react with anything. So noble gases are what is called inert. Inert means unreactive, fully happy with their full outer shell. So they don't need to interact with anybody. They think they're the best, they're happy, they're great, and they can be left alone. Nobody, no other element will bother with them. Okay, I'm going to use a pink color down here on the bottom. This whole row, which is part of group 3, don't forget that this fits right into group 3 right there. So all of these elements, which are called the lanthanides, which is a family, the lanthanides are in group 3 and they are period 6. So the reason that the lanthanides are all grouped together, all of these lanthanides share the physical property of being able to, chemical property, combustibility is a chemical property. They all share the property of being able to catch on fire when struck. So what that means is, maybe if you've ever seen Boy Scouts or you were a Boy Scout yourself, where they use flint and they hit these two materials together and you make a spark in order to create a fire. All of these elements share that property. If you hit them together with some other material, you could potentially get a spark and create a fire. So in your family, thinking back to Thanksgiving, anybody that likes to play with fire or likes fire, likes to start the fire outside when you go camping, or likes to light candles. They just enjoy fire. Pyros, if you've ever heard that word before. Your lanthanides are the fiery ones that when struck are going to create a fire. And our last family, let's use gray. I'll use a darker color. Your last family, this entire row down here, these are called your actinides. Actinides all share the property of being radioactive. Now, radioactive is a little bit different than the word that we've used before, reactive. So reactive and radioactive are different. The actinide family, all of these elements are radioactive. And what that means is that their nucleus is unstable. Just the whole atom in general is very unstable and unable to be held together. So it starts to fall apart, and these particles are just let out into the environment, which can be very dangerous. So when you think of radioactive elements, they're elements that you don't want to be around, that need to be contained in a special sort of way so they don't harm the environment or harm people around them. So your actinides, those are the family members you want to stay away from. Maybe these are the ones that hang out in the basement away from everybody. They're a little crazy, a little dangerous. They are unsafe, radioactive. One tip to help you remember which one's the lanthanide and which one is the actinide family. If you look at this element that starts at the very beginning of the row, the lanthanides start with lanthanum. So they start with element La. And then the actinide family on the bottom, their element, this element right here, is actinium. That's actinium, Ac. So if you forget which one's lanthanides, which one's actinides, The top row starts with LA and the bottom row starts with AC.